So coming up, we have a question asking us what is exponential notation. What is exponential notation? Right. So exponential notation is just another way of expressing numbers, and let's write it in here. 4 is written in the form of a to the exponent of n. Yeah. So which is a little n on the right top of a, and in this case it just means a is multiplied to itself n times. A is multiplied to itself n times, which just means a times a times a times a times dot 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 times a, and there are n of a in total, and we just times them together. And second thing is, in this case, a is what we call the base. Well, n is our power, or is it exponent, or is it index? So the power, exponent, or index. Right. So if I say 2 to the exponent of 4, in this case, 2 will be our base, and 4 will be our exponent. So that's like an example of it. Alright, so coming up, if we got a, let's say, 3 to the exponent of 4, which is equal to 81, then it is just equal to 3 times 3 times 3 times 3, right? So we said it is multiplied to itself n times, so in this case it will be 3 times itself by 4 times. So 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, right? And also here, 81, we can also express as the product of its prime factors, which is just 3 times 3 times 3 times 3. And we know 3 is a prime number. Right. And yeah, so the second part of the exponential notation will be what we call the scientific notation. I'll write it down here. Scientific notation. Yep. So it is a specific example of exponential numbers where 10 is almost always used as a base number. So let's write this down. A specific example of exponential numbers where 10 is almost always used as a base number. It's the base number. Right. And yeah, so to convert a number into a scientific notation, we express all such number as coefficient between 1 and 10 and followed by an appropriate power of 10. So I'll write this down and then I'll give you an example of that. So to convert a number into its scientific notation, we express all such number as coefficient between 1 and 10, followed by an appropriate power of 10. Okay, so now if we say we have an integer 138,000, so this we can, in scientific notation, we can rewrite it as 1.38 times 10 to the exponent of 5. Right. And you can see for this part, 1.38 is between 1 and 10. And for the second part, it's just a proper power of 10. And so if we have, like, say, 138 times 10 to the exponent of 3, this is not going to be correct since the first part is greater than 10. Okay? Yeah. So here we express, I'll move it on the side. So this is correct. Yeah. So here we express our coefficient as a number between 1 and 10, and hence we need to have only one digit to the left of our decimal point. Yeah. So I'll write it on here. So 138,000 is equal to 1.38000 times 10 with exponent of 5. And the reason why is exponent of 5 is that we imagine there's a, oops, change the color. We imagine that's 138,000.0 is equal to the right hand side. And now we need to move the decimal 5 times in order to get 1.38. So that's 1, zoom in a bit. So that's 1, 2, 3, 4, and 5. So the decimal point will move to here, and that's exactly what we want, 1.38. So therefore, the exponent should be 5. Yeah, so we go 1.38, and then we count the decimal. Let me write this down. So we get 1.38, and then count the decimal places from the rightmost digit up to the first digit. And that will be the exponent. Be the exponent of our base 10. So let's do another example. If we have, let's say, 0.00058. Yeah, and now I want to convert that into a scientific notation. So how are we going to do that? So first, this is going to be equal to 5.8 times 10 with exponent of -4. Right. Yep. So here we express our coefficient as a number between 1 and 10. And hence we need to have only one digit to the left of our decimal point. Oh, and so same thing here. If we say I got a 58 times 10 to the exponent of 5 and of -5, this is also going to be not incorrect. I mean not correct, since this part is greater than 10. We always need to make sure that the coefficient is between 1 and 10. Okay? So let's do the decimal moving. Right. Okay. So in order to get a 5.8, we need to move the decimal point to the right for a certain unit. And now let's see how many units we need to move. So the original decimal point is right here. It's right here. So that's going to be 1, 2, 3, and 4. So it moves to here, 5.8, and that's exactly what we want. So we got 4 there, so hence the exponent should be -4. Alright, so I'll write this down. So we get 5.8, and then count the number of decimal place from the original location of the decimal point. And that will be the exponent of our base 10, but will be negative. Yeah. Okay. So if this number is less than 1, after we converting them into a scientific notation, the exponent of 10 is always going to be negative. And if we got this part, like 1.38, like the example we have about, this part is greater than 1. So in this case, if we want to convert this into a scientific notation, the exponent of 10 is always going to be greater. I mean, it's always going to be positive. Yeah. So I can see there's 5 there and -4 there. Right. So yeah, so I think that's all we got for this question. And let's leave a comment here. Oh, correct. Good job.